In 2017, astronomers using NASA's Kepler telescope found hints of evidence of what they thought could be the first exomoon ever detected, a moon orbiting a planet outside our solar system. A lot of people were very excited about the potential discovery, and the research team requested time on NASA's Hubble Space Telescope to see if there was truly a moon. Now, the data from Hubble is in and processed. Have scientists found our first exomoon? Looks like they still need more observations to be 100% sure. The moons in our solar system are very diverse, some with liquid water, some that are potentially habitable, so being able to observe moons in different solar systems would give us a whole new treasure trove of interesting worlds to study. The team of astronomers from Columbia University sifted through data from 284 Kepler measurements of transiting exoplanets. A transit happens when a planet passes directly between us and its star and blocks out a small portion of the star's light, which produces a dip in the amount of light coming from that star over time, called a light curve. If there's a moon on either side of the planet, we might be able to see a second, smaller dip in the light curve. Making transit measurements and processing the data into a light curve can be very tricky though, so scientists need to observe multiple transits in order to get convincing evidence of an exoplanet or an exomoon. Out of the 284 planets the team looked at, they found one planet with an extra wobble in its light curve that might be a moon. This planet, Kepler 1625b, orbits its star once every 9.5 months, so it takes years to observe multiple transits. The team only had Kepler data from 3 transits of this exoplanet, so they sent a proposal to the Hubble Space Telescope to capture more data of this possible exomoon. Hubble can measure light curves much more precisely than Kepler, so Hubble can more definitively confirm or disprove the existence of this exomoon once it gets multiple transits. So far, the team of astronomers has collected Hubble observations of one transit of exoplanet Kepler 1625b. Hubble measured the light coming from the star over a period of 40 hours. About 7 hours into the observation, the planet started its transit, which was about an hour earlier than predicted. A tantalizing piece of evidence that the planet has a large moon, because a moon would cause the planet to wobble in its orbit. The planet transited across the face of its star for 19 hours, as expected. Then, about 3.5 hours later, a second, smaller dip in the light curve started. That right there is intriguing evidence of an exomoon. The Hubble observation unfortunately concluded before the possible moon finished its transit, so Hubble hasn't yet observed a full transit. This light curve appears like it shows an exomoon, but we can't say it's a definitive detection until Hubble observes at least one more transit. If this is actually a moon, what do we know about it? The planet Kepler 1625b is likely several times the mass of Jupiter. Its possible moon appears to be about the mass and radius of Neptune. The ratio between the mass of this planet and its moon is about the same as between the Earth and our moon, but scaled way up. Neptune-sized moons are obviously not something that exists in our own solar system, and we're not sure exactly how such a moon would form. When scientists first started discovering exoplanets, a lot of them were several times the mass of Jupiter because big planets are easier to detect. So a similar thing may happen when discovering the first exomoons. Finding planets and moons so different from the ones in our own solar system gives us a lot more knowledge of the many diverse ways planetary systems can exist. In the near future, scientists hope to use the Hubble Space Telescope to try to confirm the discovery of this exomoon, and then they'll use Hubble for follow-up observations of other planetary systems discovered by observatories like Kepler and the recently launched Transiting Exoplanet Survey Satellite, TESS. And then the upcoming James Webb Space Telescope will be able to take high-precision measurements in infrared wavelengths, which combined with Hubble will allow for detailed characterizations of a whole bunch of really interesting exoplanets and likely exomoons. So, if you like planets, and honestly, who doesn't? Stay tuned to learn about all sorts of fascinating new worlds.